In this video, we want to find the domain of the given functions here. So when finding the domain of a function, you have to remember that you're looking for the permissible replacements of the variable. In this case, it's x. So you have something involving x and y. The value of the x, permissible values of x will give you the domain. Permissible values of y will give you the range. And we're only looking for real numbers. So the domain has to consist of real numbers, not imaginary numbers. So let's look at the first one. This is a polynomial of degree 2, f of x equal to x squared plus 2x minus 7. Are there any values that you have to eliminate? If you replace the x by any number and square it, and then multiply it by 2, and then subtract 7 from that, does it give you something that's not defined or not real? And the answer is no. X can be any number. So the domain, we can say it's a set of x, such that x is any real number. Or sometimes you can give it in terms of interval notation from negative infinity to infinity. Or you can just say all real numbers. Now if you have a rational function, like the second one, the main thing there is you don't want any values for which the denominator is equal to 0. In other words, numbers for which the function is not defined. So in this type of problem, you simply take the denominator and set it equal to 0, and then find and see if there's a solution. So in other words, solve this equation for x. So first we can factor out an x, and we get x squared plus 1. So you got an x squared and you got a plus. If this were a minus, that would be different. But x squared plus 1 is not going to be 0 for any value. So in other words, you set each factor equal to 0. So x here can be 0 in the first factor, but because this is a square here plus 1, the second factor can never be 0. So the only solution you have to this equation is x equal to 0. So that means that the only value that you have to eliminate is 0. So we can write this as, okay, the domain for the second one, I can write it as an interval notation, but I'd write it this way. It's a set of all x such that x cannot be 0. And then another way to write this also in interval notation, I could say it's everything from negative infinity to 0 together with, or union with, everything greater than 0. And that's just another way of saying everything except any value except 0 will work for that one. Okay, for the next one, we have a square root. G of x is equal to the square root of 3x minus 7. Well, here what you have to remember, again, we're talking about real numbers. So since this is under a square root, anything will work as long as the radicand, 3x minus 7, is greater than or equal to 0. You can take the square root of 0 or the square root of any number greater than 0. If it's less than 0, that's going to be negative here in the radicand, so that would be imaginary. So here we just have to solve this equation here, for this inequality, I should say. So we add 7 to both sides, here and here, so I get 3x greater than or equal to 7, divide by 3, both sides by 3, so we get x is greater than or equal to 7/3. So we can say the domain is all real numbers greater than or equal to 7/3. Or we can write it in interval notation and say the domain D be anything greater than or equal to 7/3. So brackets means the 7/3 is included because I have the equals here. Never have brackets on the infinity part. That's your domain. Any number greater than or equal to 7/3. And on the next one, we have a log function. P of x is equal to the log of x squared minus 25 to base 3. Here we have to remember that when you take a log of some number or some expression to a base, the expression has to be positive. Can't take the log of 0 or a negative number. So here we just go ahead and say, okay, this is going to be, in order for this to be defined, x squared minus 25 has to be greater than 0. Log of 0 not defined. So x squared minus 25 has to be greater than 0. So this just amounts to solving an inequality. So let's factor it on the left side. x squared minus 25 factors into x minus 5 and x plus 5. And then we can draw a number line here. We find the zeros out of this left side. So x minus 5 is 0 at 5. So we put a 5 there. And x plus 5 is 0 at negative 5. So we can see then if I pick a number larger than 5, say 6, put it in here, 6 minus 5 is positive, 6 plus 5 is positive. The product is positive, so I'll put a positive here. Notice to pick a number between negative 5 and 5. It could be 0 or 1, any number be in between. Let's pick 1. 1 minus 5 is negative. 1 plus 5 is positive. A negative times a positive is a negative. So I pick any number between negative 5 and 5. X squared minus 5 will be a negative number. If I pick a number less than negative 5, any number in this range here to the left of negative 5, say negative 5.5, negative 5.5. It could be negative 5.1, as long as it's to the left here. So negative 5.5 and a minus 5, that's negative. And then negative 5.5 and 5, that's negative. Negative times a negative is positive. So my solution set lies wherever the plus sign is, because that's what we want. We want this to be x squared minus 25 to be greater than 0. So that means we can pick any number larger than 5 or any number less than negative 5. So for the domain D, remember infinity, positive infinity is over here on the right side, and negative infinity is over here. So my solution set is in this interval and this interval. I simply write negative infinity to negative 5 union 5 to infinity. And this is my solution set. Negative infinity to negative 5 union 5 to infinity. And remember, because I have parentheses here on the negative 5 and on the 5, those are not included, because 5 would give me a 0. Negative 5 would give me a 0 in there. And the log of 0 is not defined, no matter what the base is. Thanks for watching. We'll see you next time.